Well, I've got the wrong numbers. You can see this is going to be a dim lecture. 45th anniversary. It's really the 46th. I miscalculated. I don't know. That's a number of years. 46 years ago, that's before quite a few of you were born. Huh? You're lucky to have made it because 60 million people didn't partly as a result of Roe versus Wade. A few facts about Roe versus Wade to get you all up to speed. It all began with a law in Texas, or laws in several states. They forbid abortion, as I say, except to save the life of the mother. A lady by the name of Norma McCovey became pregnant, was not married, wanted an abortion, and couldn't get one in the state of Texas, and she said she couldn't afford to go to a nearby state where she could get. And Henry Wade, who was a Dallas County district attorney in Texas, back in 1970. While the arguments and the debate went on, she actually went on and delivered her baby and gave it up for adoption. In January 22nd of 1973, the Supreme Court had a 7-2 decision. They had been arguing over it from 1971 to 73. It was a 7-2 decision that held, in quote, a woman's right to an abortion was protected by her right to privacy under the 14th Amendment. Actually, the word privacy appears nowhere in the Constitution of the United States, but that was the argument for it. Abortion was declared to be legal, particularly during the first trimester. Almost nothing could interfere, but the states were given limited control over the second and third trimester. For example, it could be argued that if the health of the mother was involved, then you could have abortions during the second and third, and that health of the mother could be just that the mother says, I'll just go nuts if I have this child, and that would suffice. How about this one for irony? In 1997, Norma McCovey, known as Jane Doe in the court dockets, who was behind this whole decision, changed her views on abortion and started a pro-life organization called Roe No More. And she supported the pro-life position up until her death some years ago. Well, what was the result of Roe versus Wade? You can see it in this number of reported abortions. If we look at the beginning here, 1973, when Roe versus Wade decision came down, within 7 years, abortions had doubled to 1.6 million. It continued at that rate until 1990, and thank the Lord, it's been diminishing ever since. We're almost down to where we were when we started Roe versus Wade. Why is that? Well, I think the pro-life movement has been very effective, and I also think very important is sonogram imaging. Now even in 3D in movies, we can see the baby in the womb, and people can see it's really a baby there, not some tumor or whatever. Nonetheless, 60 million, hard to even grasp a number like that. Since the Supreme Court decision, basically, you can maybe understand a little better this way. That averages out to more than 3,650 abortions per day and 150 abortions per hour. 60 million altogether. Well, I wanted to talk to you a little bit about these basic questions of when does life begin and all that comes up. Actually, that question's a bad question because the baby's alive, surely, but the womb is alive, your hair follicles are alive, your nail bed for making your fingernail is alive. I don't think the question is when does life begin. Maybe the better question is when does a person begin? A unique human being that, at least from what we've been able to see, has not been observed before. And yet the Lord knew us a long time ago. Look at Jeremiah. The Lord said to Jeremiah, before I formed you in the womb, I knew you. Before you were born, I sanctified you. I ordained you a prophet to the nations. Well, we can't go there, but it means the Lord knew us even before we were born, knew us personally, and had, I think for all of us, not just Jeremiah, plans. In Psalm 139, verses 13 and 14, we read something that is close to me because It says we were knit together in our mother's womb, and my field of expertise is histology. It comes from a Greek word, histos. It means a web or a fabric. So histology is a study of webs and fabrics, and guess what? That's the name given to looking at the body through the microscope. And why do we call it that? Because under the microscope, we look woven. Our collagen fibers are woven, our keratin filaments are woven. So when we read Psalm 139, "For you created my inmost being, you knit me together in my mother's womb. I praise you because I'm fearfully and wonderfully made. Your works are wonderful, and I know that full well." In other words, that's obvious. The psalm goes on to read, "My frame," I guess that would be our skeleton, "my frame was not hidden from you when I was made in the secret place." To me, this is the best argument for pro-life there is. The Lord was looking on as we developed. He knew us, had already called us, and we were made in the secret place. That's kind of an interesting name for the womb. It's still a lot of secrets there, but we know more about it than the average person did when this was written. "When I was woven," there it is again, "when I was woven together in the depths of the earth," another euphemism for the womb, "your eyes," that is God's eyes, "saw my unformed body. All the days ordained for me were written in your book before one of them came to be." Well, we can't go there. We can't see that. We just have to take it at God's word. We have to go with what we can see. When is a baby first formed in a way that we can understand and know this is a unique human being? Quick look. Here it is, the uterus, where everything happens, the secret place, depths of the earth, as it were. A muscular body with two tubes extending from it called oviducts, which simply means egg tube, and on the end is a funnel, and the funnel does what funnels do. It catches the egg, so it doesn't miss. The egg is ejected from the ovaries. You see the one on the left and right there? They're about the size of a almond, so plenty big enough to see with the eye. You would need a microscope. And if a lady's regular every 28 days, an egg will be ejected from that ovary. And the ovaries are courteous. They take turns, one side and the other. If we remove one ovary, the other ovary has the considerable good sense to go ahead and ovulate every 28 days rather than every other. So let's look at the ovary quickly. This is just a diagrammatic view. We see these little primordial follicles called developing follicles here. When a baby's born, she has all of the follicles, all of the egg follicles that she's ever going to have in her whole life. They never get any more. It's about 500,000, so that should suffice, 400,000 or so. And then when you reach sexual maturity, about every 28 days, about 40 of those will start to mature, of which typically one forms this big one you see to the right up there called a Graafian follicle, sometimes more than one. Then you have an opportunity for twinning. Fraternal, not identical. It could be a boy and a girl, 2 different eggs, 2 different sperm. The egg's ejected, caught by the funnel, and now it's in the oviduct. What's left of the egg, the cells that you see in that kind of a ball-like structure there, go on to form an endocrine gland, shown in yellow here. In fact, that's its name, the yellow body, corpus luteum. And it produces progesterone, which is important to get the uterus ready to receive the implanting conceptus or blastocyst. If pregnancy doesn't occur, this gland breaks down. And this gland is big. It's like 2 to 4 centimeters across. You don't need a microscope to see that. And when it breaks down, it forms a scar about that big, 2 to 4 centimeters, called a white body. And every 28 days, you get another scar. How long do you think this can go on before it's all over? Ovaries of massive scar tissue. Boy, have I got good news for you. The only place in the body where scars are absolutely dissolved to nothing is in the ovary. I've got a scar I've had since I was 16 here, it's still here. But in the ovary, it's dissolved. If it didn't, we wouldn't be here. Well, that's a cutaway of the whole system here, the uterus, the oviduct, the ovary. You can see it's kind of wrinkly inside the oviduct. And when the egg is released, it typically lands in the first third of the oviduct, and it'll generally be fertilized in that position. After it's fertilized, it's really technically not an egg anymore. So a fertilized egg is a kind of a misnomer. It becomes something we call a zygote. And it's very important that the zygote move down the oviduct to the uterus. If it stayed where it was fertilized, you would get a tubal pregnancy. The reason you don't get a tubal pregnancy is where the green box is. There are special cells that have hairs on them called hair cells. That's not too complicated. Actually, they're just ciliated cells, and these cilia beat like a sort of like a whip, like this. And that's what beats the conceptus or zygote down to the uterus. Now, how is it going to beat? Can't beat just any old way. If it beat like this, that wouldn't move anything. If it was like window wipers, it wouldn't work. How does it beat? You're all familiar with it. You've probably all practiced that beat yourself, huh? You know what it is? It's the wave. Ever do the wave at a ball game? It's the wave. Technical name, metachronal rhythm. It's what you see when wind blows across a wheat field. This motion and no other will move the egg, or I should say the conceptus or zygote, down the oviduct. Mess this one up, anything else you do doesn't count. Evolution gives no partial credit. Doesn't make any difference how good one thing is, something else can be the end. Well, the egg does go down the oviduct, and we're going to talk about a week here. From the time of fertilization until it implants in the uterus takes about 7 days. And here you see the egg has arrived at step 1. I'll show you what it looks like in a photograph, cross-section of the oviduct. That's the egg. See how big it is? It's the gray thing in the middle there. That's big enough to see with the human eye. It's about the size of a grain of salt. And there's some cells that accumulate around it that have been given a clever name, the cells that accumulate around the egg. Cumulus oophorus. They're important because the cilia grabs those to move the egg down the oviduct. No cumulus, the egg doesn't go anywhere. Here's a magnification of the egg. Look how small the chromosomes are over to the left there in the egg compared to the rest. If you know about meiosis, this is the arrested meiotic metaphase of the second division. It will not complete unless a sperm enters the egg. Around the egg is a clear zone, naturally called the clear zone, the zona pellucida, and it's our eggshell. Yeah, we have an eggshell. You probably didn't know that. Well, 12 to 24 hours is usually the window of fertilization, though it can occur in rare cases as early as 30 minutes from coitus, and can occur as late as 5 days. Sperm can sometimes be stored in the oviduct for that period of time. In fact, sperm need to be in the oviduct for a little while to be what we call capacitated. There's some chemical changes to the membrane without which fertilization is impossible. So you have to throw capacitation in here. Talk about ganging up on somebody. For one egg that's been ovulated, there's approximately 150 million sperm. A dozen or so will find its way to the egg using heat-seeking, chemotactic mechanisms, what have you. No more than one sperm can be allowed to fertilize the egg. What happens if two get into the egg, it breaks down before fertilization happens. So there's a mechanism to prevent polyspermy. Of the dozen sperm, one of them manages to digest its way through the cumulus, which takes a special enzyme. It takes another enzyme to get through the shell, the zona pellucida, and then it finally gets to the egg membrane. Even though they're two different human creatures here, or from two different human sources, I should say, it should be biologically rejected, but isn't. The sperm is taken into the egg, but not the way the picture's shown here. It shows the mid-body of the sperm going in. That's the mitochondria. The male mitochondria never enter the egg. That's why we can do these interesting experiments on mitochondrial DNA. It's all from the mother. It doesn't come from the father because the father's mitochondria are left out of the egg. Well, you have a sperm inside the egg. Is that fertilization? No, that's not. I'll show you. This is a human egg. The granules you see there are yolk granules, basically, that are used until you can get implanted in the uterus. There are two structures called polar bodies, or pronuclei, rather. That's what the PN stands for. So the chromosomes from the male and the chromosomes from the female are still separate. We don't have fertilization. They each make a nucleus. Now these two nuclei come and fuse. And when the two pronuclei fuse, that's the beginning of a new human being. That is the official start. Genetically unique, nothing like it has ever existed on Earth before. But oh my goodness, the world has all kinds of ways of interfering. I was a consultant for several editions of Stedman's Medical Dictionary. I was a consultant in 1995, 26th edition. I wasn't in charge of the word conception. I was in charge of all of the words that had to do with cells of the body or tissues. But in conception, it was defined as the act of conceiving or becoming pregnant, fertilization of the oocyte or ovum by a spermatozoa to form a viable zygote. That's a perfectly good definition of conception. It's the same thing as fertilization, synonyms. But look what happened in a 27th edition. I was still on board. It was my last year at the university and with Stedman's. In 2000, they took that part of the definition out and brought this in. Now it reads, conception is the act of conceiving the implantation of the blastocyst into the endometrium. Depending on how you calculate it, they just bought 9 to 10 days from fertilization to argue it hasn't happened yet. That allows Plan B to be marketed as not interfering with conception. Very clever. By the way, the dictionary has changed back and forth 4 times. Shows you there's a battle going on. I'm no longer on the staff of the dictionary. Well, here we are at 30 hours. Our 1 cell has become 2 cells. I'm going to show you the youngest human being you've ever seen right here. That is a 2-cell human being, and you can see the eggshell around it. If the eggshell wasn't there, those 2 cells would separate, and you know what happens then? You get 2 people instead of 1. You all could have been 2, 3, 4, or more, but you're 1. That's heady, huh, to think about that. You'd be a clone. That's how you get identical twins. Well, that's the 2-cell stage, and here we go to 3 days. 2 cells become a ball of cells. And at 4 days, there's even more cells in that ball. We call it a morula. That's the scientific name for a raspberry because it looks like a raspberry, a bunch of little bumps on the surface. Now, I want you to notice something really is going to blow your socks off. You notice nothing gets any bigger? We're getting more and more cells, but that ball's the same size as it was when it was a single egg. And oh, is that important? Because if it did what cells normally do, when you divide, grow back to a full size again, it would have got bigger and bigger and clogged the oviduct. That was close. We could have lost it right there. They stay small until after you're out of the oviduct, then they grow. How's dumb luck working for you so far in all of this? Okay, here we've made it to 4.5 to 5 days. Our solid ball of cells has become a hollow ball. We call it a blastocyst, and this is what it looks like from a human being, 107 cell stage. And it's liquid-filled, hollow ball. You might wonder, where's the baby in here? The baby's right there. It's called the inner cell mass. You're probably wondering, what do all the cells in the ball do? They're called trophoblasts. They make the placenta. So you can't just make the baby, you have to make the placenta, too. It's getting complicated, isn't it? Look how big that blastocyst is. People say, is God concerned about something this size? You're going to call this a human being or a baby? I have to go back to Job to get straightened out on that one. Job asks, what is man that you, that is God, should exalt him, that you should set your heart on him, that you should visit him every morning and test him every moment? Yeah, the Lord loves even that conceptus, even that ball of cells. In fact, if you think about it, Jesus didn't come into the world as a 30-year-old itinerant preacher. He came into the world as a zygote. And he was a 2-cell stage, he was a morula, he was a blastocyst, he was an embryo, he was a fetus, he was a neonate. And he died for the sins of all of these kids, because we all come into the world, as King David said, in sin his mother conceived him. Jesus witnessed all those situations and died for all of them, because death can come anywhere in this process. Well, here we are at 5.5, 6 days, and implantation is just starting. It's like planting a seed. Notice those little squiggly things in the wall of the uterus. Those are the uterine glands that were encouraged by the progesterone that was made early on by the yellow body. And that will be the baby's second source of nutrition after yolk. Now it'll be a sugar-rich material. And those glands, and what will be next? The placenta. 3 completely different mechanisms of nutrition, all triggered one into the next. Well, this is what it looks like as it penetrates. The blue cells are making the baby, the red are the placenta, and they're burrowing right through the endometrial wall. Well, we've jumped over a lot of steps here. We're at 7 weeks. It's been shown a baby can feel pain at 7 weeks because its central nervous system is pretty well intact. In fact, 99% of the muscles in the baby's body are already forming. The deciduous teeth are beginning to appear. Detectable brain activity. At 8 weeks, the baby changes names, goes from an embryo to a fetus. Basically, at 8 weeks, all the differentiation in the organs is complete. Now we're just talking about maturation and growing in size. This is 12 weeks. At 12 weeks, baby could be fingerprinted. Jennifer would be interested in that. Yeah, he's got fingerprints at 12 weeks. And by the way, identical twins have different fingerprints. How about that? It has fingernails, facial expression. We have 45 muscles we use just to drag our face around for facial expression. It was the only language that wasn't confused with the Tower of Babel. You can go to any country in the world, primitive tribes, a smile is a smile, a frown is a frown. The baby swallows, in fact, it drinks amniotic fluid. It responds to touch, grasps things placed into its hand, and you want really evidence it's a baby, it sucks its thumb. How big is it at this point? You can't tell by looking at the picture. I have a life-size model right here. 12 weeks. This would be the end of the first trimester. Abortion's fair game up to here without any complications at all, according to Roe versus Wade. What does a baby look like? Well, we can get a really good look now that we have 2D and 3D and even 4D. 3D is when you see the baby with depth, and 4D when you see him move. And here he is moving, a 13-week fetus. Look at the hand, the face. You see facial expressions. You see the mouth form almost like words. Notice the eyelids are closed. The eyes started open, but before the baby could get its hand up and tear its eyes out with all of its movement, the eyelids actually seal shut and stay shut till about the 7th or 8th month. Well, you weren't going to get through this lecture without seeing my grandson. He was born 2 months premature, so that's a 7-month baby you're looking at there in the neonatal intensive care unit. He made it okay. I like to look at that picture because that was the age of John the Baptist when Mary visited Elizabeth. They were both pregnant. Jesus was a little younger yet in Mary's womb. And when they met, we read in Luke chapter 1, verse 44, Elizabeth said, "Indeed, as soon as the voice of your greeting," Mary's greeting, "sounded in my ears, the babe leaped in my womb for joy." What did he have to be joyful about? I'm going to leave that thought with you. Thanks.